So hello everyone, hope you're doing good and welcome back to our channel. Today we are at day 6 of the April Daily Leetcode Challenge and finally we are back with the graph problems, right? So in this question we are given a map. Okay, what a map is? Map is like a satellite view of a region, right? Map is a satellite view of a region. What happens here is we are given a map in which some regions are identified as water regions and some regions are identified as land regions. And what we have to do is we have to find the number of closed islands, which is exactly the number of the question. So today we'll be seeing this question and it's question 1254, right? So what we are given is we are given a map of it. Map means like the satellite image, okay? The region is marked with one. See, it's a 2D matrix first of all. We are given a 2D matrix called grid. It consists of only zeros and ones. Ones represents the water region, and zeros represent the land region, okay? So it's basically a 2D matrix. It may not be a square. It's just a 2D matrix, right? And the see, now I have told you almost everything except what is the definition of closed islands. Closed island means it should be it's surrounded by water along its four dimensions, along its four directions. What it means is, for example, consider this zero. Okay, consider this zero. This zero has water. That means the cell one to its right, left, top, and bottom. That means it's surrounded along the four directions with water. That means it's a closed island. Okay, that is the definition. See, because now you will say that this zero has zero. Like it's see, we are considering only four directions for classifying a given land as closed island. Okay, we are not considering the eight dimensions. Eight dimension will come in some other problem, but in this problem we are considering only the four directions. Okay, so that is the basic idea of it. See, make this question very clear because initially many of them are having a doubt like how to understand this question. Okay, so if you are having if you are having a land and a top right, see top and bottom, right and left, if you are surrounded with water, then it's classified as a closed island. That is the basic definition of it. And it need not be on a single cell, it can be on multiple cells as well. For example, see this region, it all starts with zero. Okay, above it all are waters. Similarly, consider this row, left of it, like the left of it all are waters. Similarly, consider this row, bottom of it all are waters, and this row. So this region is also a closed island. In between, see, there's a water, but that is fine. Definition of closed island: it should be surrounded by water along its four directions. Okay, that is the basic definition, and that's why you see the answer as two. Okay, so what are the two regions here? Here, see this zero. First of all, this zero has water along its top right, bottom, and left. Similarly, this see my mouse pointer. This row, if you are seeing, okay, this row, then this column, this row, and this column. Okay, these are all surrounded by water along all its four directions. That's why it's a island. Okay, this is simple. Now you will ask me why we are not considering this particular column as a closed island. See, because they have clearly mentioned to be surrounded by ones. If some land is along the the edge of it, along the boundary of the grid, then it cannot be considered as a closed island because it's not surrounded by water along. See, it should be surrounded by water after all, right? Within the grid. Okay, within the grid it should be surrounded by water. So one thing you can like very clearly make out of it, see, this is a hint actually to solve this question. If a land is present along the boundary of the grid, it will not be considered for a closed island. So whichever land is connected with, everything will not be considered for a closed island. So okay, these zeros, this zero, all of these are not will not contribute to a closed island. Okay, because see, it should be surrounded by ones. If it's at the border of the grid, then it cannot be surrounded by one, right? So it should be surrounded by one along all four directions. So if some of the directions are not possible within the grid, then it cannot be considered to be a closed island. So that was all about this problem. And coming to example two, see example one we discussed already. Okay. Coming to example two, see this is a grid given to us. Ones represents the water, zero represents the land. We can clearly see this particular zero has water to its top and bottom, left and right. Okay, this particular zero. So the answer is one here. The number of closed islands is one. Now coming to the example three. See, consider. See, I hope you are able to see my mouse. See, consider these things. This row, okay. Then this row, then this column, and this column. Okay, this particular column. So this all zeros we are seeing, right? This all zeros. Similarly, this column. This all zeros we are seeing, right? So this is a one of them, and this is zero is another one. Okay, this zero, if you can clearly see, surrounded by all waters. So this is contributing to the answer, and there is a one set surrounding it. Then above those ones, you can see there is exactly a square of zeros. Okay, that is also going to bring the answer. So total answer is two. See, the matrix given to us will be of highest length, and see highest dimensions of it could be 100 into 100. Okay, so we can use the O of n square approach because it's not a big number, and the grid will always have either land or water. It won't have anything else. Okay. So coming to the questions and see what are the approaches we can use. See, whenever I see this kind of matrix given to me, maybe you can use some matrix algorithms, but I will always consider this to be a graph. Okay. Whenever I consider this to be a graph, I'll be using only either BFS or DFS. And see, if you are very thorough with dynamic programming and other stuffs, you can also use union find. Okay, you can also use it will use recursions and dynamic programming. So you can also solve it using union find approach, but in this particular video I will be using BFS approach to solve this question. Okay, so we are at day 6 of the daily code challenge and it's a graph problem. Okay, now coming to the solution of it, see, I'm declaring the number of columns, see, number of rows as m, number of columns as n. Okay, see, please keep these things in mind. It will be very easy for you to understand the solution, see, because there are so many things involved here, like this kind of things. If you're not sure which one is the row, which one is the column, then definitely you will be struggling. Okay, so this is number of rows. Please note it down somewhere. This is number of rows, this is number of columns. Okay, visit is a m cross n. Okay, it's same as the size of the dimensions of the grid. It will be a matrix in which all values will be initialized with false. So this will donate which all lands we have already visited. Okay, which all land we have already visited. See, water we will never visit. Only lands we will be visiting. Okay, and this is the BFS function. Okay, this is the BFS function. I will come back to it. So, but what how we are like calling this function? That is the question here. So yeah. Like, see, we are doing a two for loops. What is the idea is we are going through each of the grids element. Okay, we're going through each element of the grid. We're using two for loops for that. One for loop for the row, one for loop for the column inside that. Okay, we are going through each of the elements, and if it is a zero and it's not visited, that means if it's unvisited land. See, these two, so the highlighted part means if it is an unvisited land. Unvisited means it's visit, see, the visit of I comma j should be false. I visit of ij will be false, and if it's a land means visit grid of ij will be zero. Okay, if these two are true, that means if it's unvisited land, then start a BFS traversal out of it. Okay, and if the BFS traversal returns true, then come back to this part and make the count as one. So finally we'll be returning count. So count will be basically the number of closed islands. Okay, so count will be basically the number of closed islands. So let us see how this thing works in the BFS function. So we are passing only I comma j to it. So we are basically like, what is the intention here is it will start the BFS also out of I comma j, and it will return the number of closed islands. Okay, no, it will return true or false. True means it's a closed island, false means it's not a closed island. Okay, so how that is being done, let us see. So in the BFS function, I'm declaring a queue. In the queue, I'm appending this particular I comma j which I'm passing. See, this I comma j which we are passing here, right? This I'm being appending. See, this becomes x comma y here. Okay, this I'm inserting into the queue. See, if you are aware about what BFS traversal is, if you have seen my past video, especially the last few questions of the March daily code challenge, okay, then definitely you will be aware of what is a queue and what is a BFS traversal, because I frequently use BFS traversals compared to DFS traversal. Okay, so if you have a time, do watch those videos as well. This kind of questions are very common in interviews because there is a lot to discuss here. Right, there are so many ways to do it. Right, so just be clear in your logic, and definitely you will be able to code it if you are strong in coding. Right. See, and my assumption here is before like once I insert something into the queue, I will be making the visited part as true. See, there are many ways of doing. Some will be popping while popping out of the queue. They will be making the visited as true. In my case, what I'm like my strategy is like whenever I pop something into the queue, I will mark it as visited. This is what I'm doing. Some previously even me I did sometimes like whenever I'm popping out of queue, I will mark it visited as true. So whichever way you want, you can do it, but follow a rhythm. Okay, it should not be either way. It should be only one way, right? So whenever I'm pushing something inside the queue, I am marking as visited. So this is how I mark it as visited. Visited of x comma y is equal to true. Okay. In this is the assumption which I'm making. See, this is the assumption. If it is not true, okay, then I will make it false as well. and finally I will be returning this. The function will return this particular value, okay, which initially is true. If I find it to be false, I will make it false in this part. Okay, I will come back to it, and finally I'm returning this as the this particular thing will return out of the BFS function. Okay, these are the various directions which I need to traverse. See, as the question clearly mentions, we are like interested only along the four directions. There are eight directions in total, right? But see, if we are trying to go diagonally, then the eight directions will come. But we are interested only in four directions. Okay? So let me explain what it means. This means don't travel anything along the x, but go up along the y. Okay, this means don't travel anything along the x, but go down. That means diagonally go below. That is travel negatively along the y direction. Similarly, this travel positively along the x, but don't travel along the y. Okay. Similarly, this travel negatively along the x. That means to the left of the x, but don't travel along the y. Okay. This is the basic directions in which we will move at a time. Okay. So yeah. So while q is not empty, this particular function will run while q is not empty. Let us see what this function does. I am popping out a value which is to the left. See, pop of zero means it will whatever is the index zero, it will pop that out. Okay. I'm calling it triple x and triple y. Okay. So now I will be adding this directions to it. So for I comma j in directions, I am adding see x and y, x and triple y are my like what I have popped out. In that I will be adding I comma j four times. Okay, because this length is four, right? These are four directions. So I will be trying all possible directions, and these are the indexes formed. Okay, after adding the directions, these are the indexes formed, call and row. Okay, if node is present along the grid's boundary, then island is the closed island is not possible. Okay, then closed island is not possible. Okay, so what we are doing, if column is greater than or equal, see if they are exceeding the diamond, see either the call or the row, if they are exceeding the directions, right? What we'll do, I will simply mark it as false. Okay, closed island is false. But I will see, I'm not breaking the for loop. I'm not breaking the for loop because don't stop here. Let zeros connected to it get visited. So the idea here is, for example, of this particular zero, if I find it to be like a edged land, okay, it's along the boundary. Okay, but I will not stop here. I will visit all the attached lands to it so that I don't visit them again. Okay, anything connected to a boundary island, sorry, a boundary land will never be a closed island. Okay, according to this question. Okay, so I'm making the is closed island equals to false. Okay, and I'm not stopping here. I will be continuing with my visiting. Okay, we will continue with my BFS. Okay, all lands at distance 1 to 8 will be visited next. Okay, that's what is BFS. If this is not the case, that means if it's not along the boundary, see this condition will be true if it is along the boundary. If it is not along the boundary, then we'll come to this condition. Okay, if it is a land, okay, what we are visiting is not water. If it is a land, and if it is not already visited, then see, I will come to this condition only if the above condition is false. What is the above condition? If it is not a along, not a boundary land. Okay, if it is not a boundary node, if it is a boundary node, then is, see, when this will be a boundary node, see, this condition is exceeding, right? So this will happen only if I comma j, only if the triple x and triple y is along the boundary. Only if it's along the boundary, these conditions will be true. See clearly, it's greater than or equal to m. When this will be greater than or equal to 1, when the column is equal to m minus 1. M minus 1 means it's along the boundary. Okay, so when this triple x and triple y along the boundary, only then these conditions will be true, right? Otherwise it won't be true. If it is not the case, we are checking these conditions. If the node nearby to the triple x and triple y is a land and it's a non-visited one, okay. If the visit equal to false, we'll be inserting it into our queue, and we'll be making its visited as true. Okay, we'll be making that particular nodes in the visit array as true. Okay, and this particular for loop will be continuing till my queue is not in. That means all corrected. See, for example, I'm starting at this particular zero. Okay, and if I see this particular zero, all the rows which are along the four directions of it. Okay, at, along connected to it along the four directions will be visited. Okay, this all these things will be visited. All of them will be marked as true. Okay, and finally, see, that's what the question is, right? Finally, we have to return the closed islands. Okay, finally we have to return the closed islands. So we are returning if it is a closed island or not. This particular condition will come here, right? This particular condition will come here. Okay. And if this is also true, we'll be counting it as one. And finally, if it's unvisited land and it's a part of a isolated island, we are doing count is equal to count plus one, and finally we return the count. Okay. If I run and show you, you can clearly see it's clearing all the test cases. And coming to submissions, you can clearly see it's a very efficient submission. It's a very efficient solution. It's clearing. It's again I have nearly 92% of the Python test cases. Okay. Coming to space and time complexity part of it, see, we are using a visit array, right? So space complexity definitely is going to be either O of m into n or greater than that, but we're not using anything else. And yeah, one more thing, for each of the node we are doing four traversals. Okay? For each of the node we are doing four traversals along these directions. So coming to time complexity part of it, we are using two for loops. Okay, we're using two for loops to visit each of the node. So it will be of O of m into n. In this part, this is one. When we're doing VFS, we are for each node we are doing four traversals. For so how many nodes are there? M into n nodes are there. For each of them we are doing four. So four into m into n. So it will be again of the order O of m into n. Okay. And yeah, friends, that's all I can say. So time complexity O of n into n and space complexity, because we are using a visit array. Okay. It will again of the order O of m into n, because it's a m into n matrix, right? So yeah, friends, that's all for today. It's a simple BFS traversal, and see, this is the first graph question in the April Daily Leetcode Challenge. If you're really interested, then please do follow my videos, because we will be solving all the questions in the April Daily Leetcode Challenge, and this is the best way to learn. Because see, if I try to teach you whole of the graph, it will take more than 1 month. But if you have one question here and there, and which you are learning what, so you are already aware of BFS, so you're learning how it's implemented. Okay, this way it will help you to prepare yourself for the interviews, because interviews will be like this only. They won't ask all questions from graph. They will ask one question from graph, one question from binary search, something like that. So have this habit of solving all the medium and easy questions in the daily liquid challenges. That is the best way to ensure that you crack a product based company, right? So that's all, friends, for today. If you are not, please do comment below, and if you like my videos, please subscribe to the channel. Yeah, thanks again.